In this video, we're going to think about market structure and also market power. So how is the market structured in terms of the number of firms and whether those firms are big or small, and then also the issue of do the firms in a particular market even have any power over the price that they charge? So some firms, what we see is that there are a lot of small firms in the market. Some markets we see that there are a lot of small firms in the market. Sometimes there's a few big firms and a lot of small firms. Sometimes there's just a few big firms or maybe even one firm. Sometimes those firms that are in a market have roughly equal size market shares. Other times that's distributed very differently. So when we think about describing market structure, that can be challenging. If we're talking about the structure of a market, the number of firms, and the size of those firms, there's not one way to do that. There are multiple ways that we could think about doing it. And one of them is by using what we call a concentration curve. And so the way that you put a concentration curve together is essentially you would rank all the firms in the industry by size, and you would let firm 1 be the biggest firm in the industry. If you had the two biggest firms had equal market share, then it doesn't matter which one you call 1 or 2. So you rank them, 1 being the biggest, down to the nth firm being the smallest. And then what you do is you calculate the percentage of the industry's total output accounted for first by the largest firm, then next by the largest 2 firms, and then the largest 3 firms. And so essentially what you're getting is a cumulative fraction. A cumulative fraction of the industry's total output that's put together by smaller and smaller firms. It's essentially like a cumulative density function in statistics. So I've got a picture here of 3 different markets where we've got a different number of firms, each with a different market share. And you can see the concentration curve. So let's start with market A. So you can see that's all of them obviously start at 0. And then you can see with market A, essentially what we've got there, you can tell the number of firms in the market by where the concentration curve hits the top. A, there are 10 firms, and it rises linearly because each firm has 10% of the market. So you've got 10 equal-sized firms. Each has 10% of the market share, so you can see that by the time you get up to that 10th firm, that's 100% of the market. Let's look at B. So B has 21 firms, and you can see that that first firm there has a very large market share. That first firm has 55% of the market, and then it kind of levels off a little bit, and it's linear from there on, and you can see that the remaining 20 firms are sharing the rest of the market, the other 45%, and each of those has 2.25% each. And then if you look at industry 3, there are 8 firms in that industry. The first 3 have 25% each, and the remaining 5 have each 5%. So these concentration curves give you a good visual way of thinking about what's going on in the market. We can also think about another way to summarize that, and that's with what we would call a concentration ratio. And so we could think of a 4-firm concentration ratio. Typically, we would abbreviate it CR for concentration ratio with a subscript 4. And that would be telling us the percent of the industry sales that are accounted for by the top 4 firms. We could also think about an 8-firm concentration ratio. If we did this 4-firm concentration ratio, let's do that one first. If we thought about the three examples that we've got, industry A, B, and C, what those four firm concentration ratios would look like for industry A is 40, would be 40%. So that, remember, industry A was, we had 10 firms, each with 10%. So those first four firms, each with 10%, have 40%. If we calculated concentration ratio, four firm concentration ratio for firm, or market B, excuse me, it would be 61.75. And then for market C, it would be 80. So you can see that at least for the first four firms, market C is more concentrated than the other two. Let's think about that. You could calculate a concentration ratio for any number of firms, but 4 and 8 are common. So if we thought about the 8 firm concentration ratio, what it would look like between A, B, and C is that with market A, it would obviously be 80. Market B, it would be 70.75. And with market C, it would be 100. Remember, we only had 8 firms, I believe, in market C. And so by the time you get to that 8th firm, that's 100% of the market. The interesting thing here is that you can see that between the 4 firm concentration ratio and the 8 firm concentration ratio, the role of markets A and B switch here. Here it looks like B is more concentrated, but then when we think about the 8 firm concentration ratio, it looks like A is more concentrated. So that just points out the limitation of using something like that. There are other alternatives. One that's commonly used is something called the Herfindahl-Hirschman index. We abbreviate it HI. Fairly easy to calculate. So if we think about an industry with N firms, the Herfindahl-Hirschman index would look like this. It would be the sum I equals 1 to N of SI squared, where SI is simply the market share of the ith firm. So if firm I had 10%, that would be 10 squared. So let's do an example for a firm with 10%, SI would be 10 squared. You could also calculate that as 0.1 squared. We could put that to a decimal instead of a percent. Doesn't matter. I believe usually they're just calculated as 10 squared rather than 0.1. It would simply change the scale of it. So this measure essentially is summarizing a couple of things that a concentration ratio does, and it's accounting for the number of firms and it's accounting for the relative magnitude of those firms. So let's think about for a monopoly. If we had a monopoly, that would be one firm with 100% of the market. It would be 100 squared, so that Herfindahl-Hirschman index would be equal to 10,000 if we had a monopoly. So that's obviously one extreme. If we calculated this for our 3 markets, we calculate for market A, it is 1,000. If we calculate it for market B, it's 3,126.25. And then for market C, it's 2,000. So it's easy to calculate. The Herfindahl-Hirschman index is also interestingly used in the sports economics literature because a big topic in sports economics is league parity. So how evenly is talent spread across a league? And so the reason we care about that is that a sports contest is only interesting if there's uncertainty of outcome. If you know the outcome, Okay, then that's an exhibition. That's not a sports contest. So that uncertainty of outcome makes it interesting. Uncertainty of outcome is hard to achieve if you have a league where there's very little parity, where the talent is concentrated in one or two teams. And so the Herfindahl-Hirschman index is used as a measure of how evenly parity is distributed across teams. So rather than looking at market share, you might look at the share of championships won over time. And if you had one team that's won a huge share of the championships over time, then that is a very similar idea to one firm that has a very large market share. Usually, if we had to choose between the Herfindahl-Hirschman index and the concentration ratios, we would choose the Herfindahl-Hirschman index simply because it's giving you a measure of both firm size and inequality of size. Another issue that we have to think about is how we should define a market. So to calculate any of these, we have to first think about, well, what market are we talking about? And that can be very challenging. So if we think about a product like, say, Pepsi, and we try to say, okay, well, what market is Pepsi in? There's a lot of options there. We could think about Pepsi being a competitor in the market for carbonated beverages. But you could also make the argument that carbonated beverages, that doesn't define a complete market. You could include fruit juices, and you could include other substitutes like teas, or maybe even milk, drinks that consumers can choose between. So I could go drink a Pepsi, or I could drink sparkling water, right? And so to define that market, we have to really think carefully about what goods serve a similar function. So Coke is clearly a substitute, but is milk a substitute for Pepsi? That's the question we have to think about. There are also lots of goods that serve multiple purposes. So if we're thinking about some good that a consumer could use, like, say, a tablet, well, a tablet could be used to be productive at work or to do homework on, but it can also be used for entertainment purposes, to stream movies or for gaming. So there are some products that it can be challenging to define the other substitutes for that product. And you might say, well, so why does that matter? Well, it matters a lot because we can arbitrarily change these measures that we've been thinking about by changing the market. So if we broaden the market, if we think about the substitutes for Pepsi as being just Coke, then we're going to get a very different number of different measure for each of these things than if we thought about it as Coke and milk and sparkling water or alcoholic beverages. So you can arbitrarily change these things by changing the definition of the market that you use. We can think about broad definitions of markets, and we can think about narrow definitions of markets. So to get guidance in how a market should be defined, there's something referred to as the NAICS. That's the North American Industry Classification System. It's just one of, there are some others out there. It's put together by the U.S. Census Bureau, and essentially what it is a classification of markets from very broad definitions down to more narrow definitions. So we have broad down to narrow, and these are given codes. These are 2-digit codes up here, and these are very broad definitions of markets. These are things like mining or the retail industry or agriculture. And then it goes on down to 6-digit, more narrow definitions. So these are things like new car dealers. And industrial building construction, baked goods retailing, things like that. The Census Bureau updates this every 5 years because things change. If we think about these NAICS codes, what we tend to see is that the Herfindahl-Hirschman index and the concentration ratios are highly correlated. So these tend to move in the same way depending upon how you're defining the market based on the NAICS codes. One of the problems, though, with these codes is that they are mainly based on similarity of production technology. So if you have two things that have very similar production techniques and materials, they're going to be placed in the same category. And that's not necessarily what we're after. What we're actually after here is two goods that may be complements, substitutes for each other in consumption. We're not, for what we're trying to think about, we're not so much worried about the production technology. So for example, you can think about products that are similar in production technology but are not substitutes for each other. So those things might be smartphones and tablets. Those two things are not substitutes, even though the production technology is very similar. Or you could think about drinking glasses and glass laboratory equipment. Those would be in the same NAICS category, but they're not substitutes in terms of consumption for consumers. Another way to look at this is you can think about goods that are substitutes for each other. So if I were going to build a house and I was looking for a floor covering for a room, then maybe I could choose between wood flooring. I could choose between wood flooring and, say, linoleum or tile. So wood flooring, linoleum, and tile would be substitutes for me in terms of consumption. I'm going to choose one or the other. But those are all three in different NAICS categories. So if you were to rely solely on this, you're not getting exactly what we're after. So that can be a challenge. Another challenge is that these codes are based on national markets, and many markets are local. So if we think about restaurants, there are national chains, of course, but if we're thinking about restaurants in a particular area, those restaurants are competing against each other, not restaurants typically in areas farther away. So these codes can be good if we're talking about some type of national market, like the market for airplanes. That's a national market. But if we're thinking about the market for things that are local, like construction, newspapers, ready-mix concrete, that kind of stuff, those are local markets. We can also think about ways of defining markets based on consumption. And an obvious choice for that would be cross-price elasticity. So if we think about cross-price elasticity, this is a measure that has to do with consumer preferences. It measures a couple of things. The sign of it tells us whether or not two goods are complements or substitutes in consumption. And the magnitude of it tells us the intensity with which they are complementary or substitutable. So if we think about cross-price elasticity, there are a number of different, every textbook has its own terminology that it uses, its own symbols that it uses for elasticities and things like that. So a lot of times in my videos I use this cross-price elasticity of demand, and usually I put IJ there. So we're thinking about demand for good I and how it responds to a change in the price of good J. Some textbooks use Greek eta, IJ. But what it is, the definition would be the change in quantity of good I with respect to a change in the price of good J, And then we have price of good J divided by quantity of good I. Now, that's a point elasticity. We can think about arc elasticity and we can think about point elasticity. If you need a refresher on the difference between the two and how to calculate them, then you should go look at my intermediate microeconomics video on demand, and there you'll find a discussion of that. This is just the slope of a demand curve, and this is the price and quantity that we're calculating the elasticity at. If that cross-price elasticity is positive, then these goods are substitutes for each other, because an increase in the price of good J would cause you to buy less good J and substitute towards good I, so you would also buy more good I. So the cross-price elasticity is going to be positive. And the larger that in magnitude it is when you calculate it, the more substitutable those two goods are going to be. There's a category that we can use to think about market definition that depends both on, or it depends on this cross-price elasticity, and it's the SNIP, SSNIP. And that stands for small but significant non-transitory increases in price, or increase in price. Small but significant non-transitory increase in price. So here's the idea. You essentially start with a narrow definition of a market. So we might think about a very narrow definition of a market would be, say, grocery stores that sell natural organic foods. So something like Whole Foods. And then what we do is we think about all of the stores in that particular market being a monopoly. So all of those stores are run by one decision maker. Would that decision maker be able to raise price by, say, 5%? So usually we're thinking about a small increase in price, 5%. And it's non-transitory, so we're thinking about raising that price by, say, 5% for a year. Transitory would mean that it's short. So can that monopoly profitably raise price by 5% for a year? And if the answer to that is yes, then this is a relevant product market. It's a good way to define the market. If the answer is no, then what that means is that if the monopoly raised its price and it wasn't profitable, then that means that consumers are substituting away from what those firms that the monopoly's goods, whatever that monopoly is selling, it's substituting away from that to other things. So if we think about the grocery store example, if the monopoly raised its price and it wasn't profitable, then that means that consumers are not shopping at Whole Foods. They've moved on to grocery stores that sell other stuff, a broader range of products. And again, if the answer is yes, if they can profitably raise the price by 5% for a year, then that means that the customers stick with it. They don't substitute away. One thing that we have to think about, obviously, with any of this is geographic area. So what's the size of the geographic area that we're thinking about? And this can be pretty challenging. So if we're thinking about some product, let's think about an entertainment product. So if we're thinking about professional baseball in St. Louis, so the St. Louis Cardinals, Major League Baseball team. Let's think about what the substitutes are for Major League Baseball in St. Louis, for the St. Louis Cardinals. We could think about other sports in St. Louis, other professional sports. So maybe the St. Louis Blues, that could be a substitute. If somebody's thinking about going to a Cardinals game and they looked at the price of tickets and saw that they were more expensive than they expected, they could say, oh, you know what, let's not do that. Let's wait and we'll go to a Blues game. So that could be the St. Louis Blues and the St. Louis Cardinals could be substitutes for each other, even though this is baseball and the Blues play hockey. We could also think about a larger area. We could think about professional baseball in the state of Missouri. So you've got two professional Major League Baseball teams in the state of Missouri. You've got the St. Louis Cardinals and you've got the Kansas City Royals. And so those are both contained within the geographic area of Missouri. Are those substitutes for each other? Is it the case that people say, oh, you know what, we're going to go to a Major League Baseball game and we're going to choose between the Cardinals and the Royals? We could think about not just Major League Baseball in the state of Missouri, but professional sports in the state of Missouri. So are the Kansas City Chiefs a substitute for a St. Louis Cardinals game? We could also think about not just sports, but other types of entertainment. So it could be that if somebody is thinking about going to a Cardinals game and they look and they see that tickets are more expensive than they expected, then maybe they go do something else. Maybe they go, I don't know, to see some other type of entertainment like a symphony or whatever. There's 1,000 other things that you could do. So geographic areas are important in these market definitions. In principle, there's no reason that we couldn't use the SNIP method for thinking about a geographic area. And in fact, the Department of Justice and the Federal Trade Commission both recommend using that type of test when you're thinking about the relevant geographic area for a market. There are other ways that we can think about defining geographic markets, and one of them is something that we call the Elzinga-Hogarty test. And the idea here is that you think about two aspects of the region that you're considering, and those two aspects would be LIFO. This stands for little in from outside. And this is calculated as 1 minus the percentage of goods that are consumed in the region but produced elsewhere. So how much stuff, it's a measure of how much stuff is brought in from outside of the market that you're thinking about. It's LIFO is 1 minus the fraction imported, essentially. So the smaller this is, let me think about this, the smaller this is, the more you're bringing in from outside. There's also LOFI, and this stands for little out from inside. This is 1 minus the fraction exported. So this tells you how much of the stuff that's produced in a particular geographic region is shipped out of that region. It's a measure of that. The bigger these are, these two measures, LIFO and LOFI, the bigger they are, the stronger the market that you're thinking about. That means that a lot is being consumed, that's produced there is being consumed there, and very little comes from outside. In terms of the correct threshold, there's been papers published on what the correct threshold is. A lot of times people recommend both of them over 75% or the average over 90%. So there's some judgment that goes along with that. We can also think about vertical integration when we're talking about a market. A lot of times a producer owns multiple steps in a production process. So for example, you may have a paper manufacturer that owns forests and maybe owns logging companies and owns sawmills and owns paper processing facilities. Or maybe Coke and Pepsi both own bottling facilities. So now this is all discussion about how to define a market and how to describe a market. We also need to think about how to measure market power. Just because a market has a particular structure does not imply a particular outcome in that market. So we really have to think about how much market power do the firms actually have in the market. A lot of times what we do is we think about you've probably seen that, I use it a lot, that scale where we've got a perfect competition on one end and we've got monopoly on the other. As kind of the range of competition, you've got one firm here and you've got lots of firms here. This firm has as much market power as it's possible to have, and these firms have no market power. And it's tempting to think, well, market power then is simply a function of the number of firms. The fewer firms that you have, the more power the firm is going to have over the price, and that's not true. There are some types, and we'll think about some models of oligopoly where you have very few firms, but the outcome is in many ways very similar, sometimes equal to the perfect competition outcome. So you can have just a few firms, maybe two firms, and those firms have no market power. So market power is not a result of the number of firms in the market. So that's why you can't look at the structure of a market and infer anything about the amount of market power that those firms have. What we need a measure of market power, a way to think about summarizing the market power of the firm. And we can do that. We can think about defining something by looking at the firm's ability to charge a price above its marginal cost. And we call that the markup above marginal cost. So what I need to do is I need to clear this off and then we'll take a look at that. If you think back to the review that we did on perfect competition, then what you hopefully remember is that with perfect competition, price and marginal cost end up being equal. For a competitive firm, price and marginal revenue are equal, and all firms maximize profit by producing the quantity where marginal revenue equals marginal cost. So for a perfectly competitive firm, it charges a price equal to its marginal cost. A monopoly is able to charge a price above its marginal cost. So if we think back to the picture of monopoly that you've seen many times, what we've got is a marginal cost curve. We've got the demand curve, that market demand curve, and then we've got the marginal revenue curve that looks something like that. The firm's going to look where marginal revenue and marginal cost are equal, so the firm is going to be producing this quantity, and then they're going to charge the highest price that they can for that particular quantity, so that price is found right up here. There's PM. Now, if we think about the marginal cost of producing the quantity that they're going to produce, all we have to do is go up to the marginal cost curve. We hit it right there, so there's the marginal cost at the margin, that's the cost of producing that particular quantity that they're producing. And this is what we call the markup. So that is an amount, a number of dollars higher than their marginal cost that they're charging for the good. The full price of the good, of course, is that distance here from that point down to the origin. So this is price minus marginal cost. We can calculate something that we call the Lerner index. So the Lerner index, often abbreviated LI, the Lerner index is simply the difference between price and marginal cost, that's the markup, divided by the price. So here's the price, and here's the markup. If we were to take the markup right here and divide it by the full price, that gives us a percentage of the price that is the markup. So it tells us what fraction of the price is the markup above marginal cost. Obviously, with perfect competition, the Lerner index would be equal to 0 because price and marginal cost are equal to each other. It's pretty easy to show that the Lerner index is actually equal to 1 divided by the price elasticity of demand. So that's not the cross price elasticity of demand that we were talking about. That's just the plain old price elasticity of demand. Let's actually take a look at that. If we wanted to think about why this is true, it's actually very easy to demonstrate. So if we think about total revenue is going to be price times quantity. Marginal revenue, all we have to do is take the derivative of that with respect to Q. Now this is a product, right? So we have to use the product rule for taking a derivative. So we write the first one and then multiply that by the derivative of the second one. That's dQ with respect to Q. And then we're going to add to that. Now we write the second one, Q, and we take the derivative of this thing with respect to Q. Now let's look at that for a second. So for a perfectly competitive firm, first off, this thing is just 1. So marginal revenue equals price plus Q times dP dQ. So let's look at that for a second. For a perfectly competitive firm, when the perfectly competitive firm changes its quantity, it has no impact on price. So if this was perfect competition for a firm, this term would be 0. When the firm changes its output, it has no impact on price. So that is 0, which tells us that marginal revenue for a perfectly competitive firm is just equal to price. But for a monopoly, that's not true. When the monopoly changes its quantity, it has an impact on price. So marginal revenue for a monopoly looks different. It looks like this term. Now what we can do is because we know the firm is going to maximize profit, we can substitute marginal cost in here because it's going to be equal to marginal revenue. So marginal cost equals P plus Q dP dQ. I'm going to move that P over here. What we're doing is I'm going to show you something related to that. So I'm going to say marginal cost minus P is equal to Q dP dQ. Let's see what else. Next, so I need price minus marginal cost instead of marginal cost minus P. So I'm going to multiply everything by -1. So I get price minus marginal cost equals negative Q dP dQ. So that should be dP right there. dP. So I'm getting close to what I need over here. All I need to do now is divide through by P. So P minus marginal cost divided by P is equal to Q over P dP dQ. I've got a negative sign there. That is the inverse of the point elasticity. So that right there is 1 over the elasticity. So this is useful. What it tells us is that the more elastic the demand curve is, the flatter the demand curve, the smaller the markup over marginal cost. And that should make sense because the more elastic demand is, that tells you that consumers are willing to move away from that good if its price goes up. And so the firm is not going to have very much market power in that particular situation. They're not going to have a very big markup. In fact, if you were to draw a couple of pictures and make one demand curve very steep and one demand curve relatively flat, more elastic, and then draw the appropriate marginal revenue curve, you'll see that the markup over marginal cost is bigger with the steeper demand curve. It's a relatively easy picture to draw. So here we're thinking about a firm. If we wanted to think about a measure of the market learner index, then what we would need is some measure of the average marginal cost for firms. Firms are not going to have identical marginal cost in practice. So we could think about a market learner index where we do something like, let's say we take price. Instead of just the marginal cost for a firm, we need some average marginal cost, and we could weight the marginal cost for each firm by its market share. So we could say minus the sum SI times marginal cost for firm I. This would be I equals 1 to N. And then divide that by price. So instead of just having price minus marginal cost, we've got some weighted measure of the marginal cost of all the firms that are in the market. So again, SI, that's the market share of firm I. The bigger the learner index, the farther we are from perfect competition. So conceptually, this is an easy idea to kind of wrap your head around. In terms of actually implementing this, it can be challenging because it can be hard to estimate the marginal costs of firms. It can be hard to estimate elasticity. So those challenges can make it difficult to actually implement it in practice. Let's think also about how big the deadweight loss of monopoly is. So if the deadweight loss created by monopoly or by a firm or firms having a lot of market power, if the deadweight loss created by that is big, then we probably need to devote significant resources to fighting that or trying to fix it. If, on the other hand, the deadweight loss is not big, then that means that maybe it's not a very big thing to worry about. So the bigger the deadweight loss, the harder we should fight it. Let's think about actually empirically coming up with a measure of the deadweight loss of monopoly, and that can be challenging. We can do a little bit of algebra and demonstrate this conclusion. The deadweight loss of monopoly as a percentage of industry sales. So this is just revenue in the market. We can actually very easily show that this is 1/2 times 1 over the elasticity of demand. Very similar to the learner index. So again, this is deadweight loss as a percentage of industry sales. So what we see is that the larger the elasticity of demand, the smaller the deadweight loss of monopoly. And again, that's not very difficult to understand, especially if you were to do what I just said and draw a picture of a market where you have a very elastic demand curve, a market where you have a very inelastic demand curve, and then think about what the deadweight losses would probably look like. If, for example, if the elasticity of demand is equal to 1.5, then that tells us that the deadweight loss is about 33% of revenue. If this was 2, if the elasticity of demand was 2, then the deadweight loss is about 25% revenue. So the bigger that elasticity is getting, the smaller that percentage of deadweight loss is getting. There's a lot of empirical research that's been done on estimating that. We don't need to really worry too much about that. Actually, the book has a section that kind of summarizes that. It's easy to do a quick Google Scholar search and you'll see lots of other research on that. What the general result is that the results depend upon the assumptions that you're making. It depends on the data that you're using, whether or not you're using firm level data or whether you're using industry level data. So there's a lot of variety of results that we see there. One of the key things that we want to keep in mind through all of this, though, is that oftentimes it's tempting to think that perfect competition is the ideal because we're comparing things to perfect competition and we're interested in how far away from perfect competition are we getting. But it's probably not possible that we could have perfect competition in every market. And in fact, it's probably not even desirable in many cases, but because with perfect competition, there's no product variety. And product variety is important to us as consumers. So it wouldn't be possible to have perfect competition in every market. But this gives us a way to think about how far away are we getting, how should we define the market, and how can we come up with measures of the power that the firms in that market have over price. So I'll see you in the next video.